Right, in this session we're going to talk about sound. So we'll investigate sound in more detail, understand the properties of sound, and we'll talk about the Doppler effect as well. So if you remember what's faster, the speed of light is faster than the speed of sound. You see the fireworks before you hear it. You see the thunder before you hear it. So sound has a speed that travels, okay? So speed of sound is actually 343 meters per second in air. This is at room temperature of about 20 degrees. If it's hotter, it will increase for every degree it rises. It will increase by 0.6. So if it's 21 degrees, this will be 343.6 meters per second. Most importantly, this is the speed that you should know. If you're solving any problems involving speed when it comes to sound, by default we will use this number. Otherwise, you can use a number given to you in the question. If it doesn't give you anything in the question, use this number. Okay, so speed of sound is less than air. You'll see it in thunderstorms, lightning, and so on. What happens if you were to travel faster than the speed of sound? If you were traveling faster than the speed of sound, you might see something like this. This is called a sonic boom. You'll hear an explosion as the air particles that are getting pushed away by the sound and by the front of this aircraft. It will explode. Very interesting stuff. So, sound itself, you can hear it when an object vibrates. It creates a pressure wave. That causes the particles to vibrate forward and backwards in the direction of its travel. So all the particles will vibrate. And the speed of sound is different in different materials. It travels through vibrations in the air, it could travel through vibrations in the water, and it can travel in the solids as well. So because water particles are closer together than the air particles, it will be faster. Again, they're even closer in a solid, really stuck together, so it's faster and louder. We did a little not a coin drop, I tapped a pen on a desk for you girls and you boys, and we were able to see, or hear I should say, the sound. It was louder when your ear is next to the table. So it's interesting stuff. And if you stretch your rubber band, you will notice that the pitch can change as well. We will talk about more of that when we're discussing the standing waves and music and things. Now, if you're talking about the pitch and the rubber bands and whatnot, the fact is there is something called a decibel meter or a sound meter. This will help us understand how loud the sound is. So the amplitude is the loudness, and we measure that in decibels. Frequency is for the pitch. So the decibels might be the same, but the pitch can be different. As soon as I make it louder, this number will go up. Here's an average decimal scale. A normal conversation's around 60 or something like that over here, 60 decibels. A quiet room will be around maybe 40 decibels. So there's always some sort of sound that you will hear. And anything below 0 you cannot hear. Anything above 130, it will cause you damage to your ears. Okay, so if you were using a decibel, just so you know that you need to make sure that the distance is constant between the meter and the source of the sound. Usually about a meter is fine. And then of course you need to know whether it's outdoors or indoors, because then you'll see the noise reflecting. You will have lots of different interferences coming from different sources in the background noises. So all of that will affect any reading that you are doing. The next thing is the Doppler effect. What happens is when an object that's emitting a sound is moving, so it emits the sound, this is a wave, that's a wave, but as it's moving you will see that the waves get bunched up. The frequency is higher, there are more waves in this area here, so the frequency will be higher. On the left hand side, as I am leaving, the waves are leaving so far away from each other, so the frequency is lower. This is why when an object is approaching you, it sounds like a higher pitch. When the object is leaving you, it has a lower pitch. And that will help us with the formula. The frequency that you hear, the frequency of the detector, will be whatever the starting frequency is multiplied by the sound difference. The speed of sound minus your speed, the detector. If you're running away, or if you're running towards it, or if you're not moving at all, this would be 0, or whatever. Divided by the speed of sound again, minus the speed of the source. So you get a little ratio here. And then you can solve it to get this. There's a couple of tips that I did give you in class about this. If you know that it should be higher, whatever your final answer is, and you don't know which number goes where for the speed of the detector and the source, put them in, and if your number is higher, you are correct. If your number is actually lower, you could just swap the two numbers around. I showed you that in some practice examples. We can discuss that again during revision. So, Doppler effect tips, this is what I'm saying to you. If it's towards each other, frequency will be higher. If it's moving away, the frequency will be lower from you. Okay, it can happen in all sorts of wave motion, even light as well, the Doppler effect. In fact, the Doppler effect for light is what accounts for the red shift or blue shift. You will notice that faraway galaxies are looking very red. It means they're moving away from us because the frequency of red is actually quite low. The wavelength is high. So that's why we can say that the galaxies are leaving us. Interesting stuff. So there are so many practice problems here. If you play this sound, traveling in a car, the car is coming towards you, so the frequency should be higher. The frequency that you hear should be high. So when you put the numbers in, you can use the formula, and you will end up getting the 343 over this. Your final answer was 564. This is actually a question that we have done together in class. So, easy stuff. That was just one example. There are many, many more examples that you can go through during the PowerPoint. Check them out yourself, please. And then you have also got all the formulas here that you need for your first exam. Thank you.